Well, hola, year 8s, and welcome again to our next video tutorial looking at this time exercise 2E, and we're nearly there. We've only a short chapter this one. There's only this video and one more to do. So without further ado, let's get into it. Alright, so this one is about polygons, and a polygon, if we haven't covered this before, I reckon we did last year, a polygon is any straight-sided shape, basically. And here's a range of polygons that we have here, okay? Um, Triangles, quadrilaterals, pentagons, hexagons, heptagons, octagons, and so on. Okay, so any shape that has straight sides and is enclosed is a polygon. We're going to come back to this slide, but I'm going to move on to this one first. So polygons, as I said, are shapes with straight sides. They can be convex, which means that all our vertices are pointing outwards, as you can see in this one. All the vertices are pointing outwards, okay? Or they can also be non-convex, where we've got at least one, could be more, as you can see here, we've got a couple, but have at least one interior angle that is a reflex angle and is pointing inwards, okay, in towards the shape itself. Okay, so convex and non-convex. Yeah, so we covered that. Convex have all vertices pointing outwards. Non-convex, or concave is another word you can use for them, have at least one vertex pointing inwards. All right, now back to this little interesting table that we have here. Now, as we already know, the angles in a triangle add up to 180 degrees, don't they? And in the last video, we saw also that the angles in a quadrilateral with four angles add up to 360. Yes, okay, we worked out that it adds up to 360 because if we drew a line, as we can see here, through the quadrilateral, split it up into two triangles, we then have two triangles, each with 180 degrees, so two sets of 180 degrees, 2 times 180 degrees, equals 3, and I'm not going to draw this because it's going to be too small. Dear. I might not bother with this one. One more go. No, it's not going to let me do it. Oh, that's horrible. 360 degrees. Okay, I am trying to write 360 degrees in there, but I can't because my pen really doesn't want to work. Can't even draw a little 2 at the moment. Anyway, okay, so if we look at other polygons, so if we then go to a pentagon, so quadrilateral has 4 sides, yes? So a pentagon, penta meaning 5, means we've got 5 sides. Now, if we do the same thing, if we go from one of the points and go out to the other opposite vertices, we end up with 3 triangles, don't we? So each of those triangles obviously have angles that are up to 180 degrees. Yeah? Alright, so number of sides is 5. Number of triangles created. So as you can see here, we've got triangles, so we've got one triangle. Here we've got a quadrilateral, so we've got 4 sides, as it says here, and we've got 2 triangles. Then we've got a pentagon, which has 5 sides, and when we split it up, it has 3 triangles. If we have a hexagon, so 6 sides in this case, okay, 6 sides, and again if we split that up, we have 1, 2, 3, 4 triangles. Okay, if we have a heptagon, so I'm going to go from here, so we've got 1, this is probably going to not work out very well, but we'll try. So we've got 1, 2, 3, 4, 5 triangles in this case. Alright, so we've got 7 sides in a heptagon, 5 triangles. So you can get what's happening here. So as we increase the number of sides of our polygon, we increase the number of triangles that are created when we go from one vertex out to the other opposite vertices. So the octagon is obviously going to have 6 triangles. All right, so to work out how many degrees, or the angle sum of all the angles of a polygon, we can then create a little formula to do that. All right, so as you can see here, if we had 2 triangles, I wish I could draw a 2. That is really frustrating me. But anyway, we will try and battle on. I'll do a big 2. 2, and then, that's really poor, 360. If we then had 3 sides by 180 in this case, and here we'd have 4 sides by 180. Whoops, 180. And if I had my trusty calculator on the screen, I would work that out, but I haven't. So that's 500, and so when we do 180 by 3, we get 540 degrees. I'm not going to write that, I'll write it out here. 540, whoops, degrees. When you multiply 4 by 180, we end up with 720 degrees. Okay, we can keep going. I'll do the last one. 5 by 180 will be the last one. 900 degrees. All right. Okay, so the number of, or the sum of the angles in a heptagon when you add all the angles up is going to be 900 degrees. So to work out, if you're given any particular shape, there is a formula you can use to work all that out. And I'm going to skip on to this one, and that is this formula, where n is the number of sides. So n is the sides given by, or the number of sides in the polygon. So if you subtract 2 from the number of sides the polygon has and multiply that answer by 180, you can work out how many degrees all the angles within the polygon add up to. Hopefully that makes sense. So if we had a dodecahedron, I'll say that really slowly, it's got 12 sides. So to work out how many degrees that has, we do 12 minus the 2 multiplied by 180. All right, so it's obviously 10 by 180. Oops, 180, which gives us, so we'll just add the 0 on this one, 1,800 degrees. All right, so I know for a dodecagon, all the angles in that polygon will end up adding up to 1,800 degrees, 1,800 degrees. All right, so it's really, really easy to use. All right, so that's probably a nice formula to have. So you can work out how many degrees a particular polygon will have. All right. Last bit of information. I think we've sort of covered everything there. We've covered all that. We've covered this. Last bit of information here is a regular polygon. So if it's regular, it means that all the sides are equal length and all the interior angles are also equal. Okay, so this is an example of a regular octagon. So each side in this octagon is exactly the same length, and each angle in that octagon is also exactly the same as well. All right. Okay, so you're going to have to use this information. So let's get stuck into some problems. I've got a blank slide. Okay, so what I want you to do is pause this video now. Okay, I want you to use that formula that we got before, so the angle sum equals n minus 2 times 180. And I want you to find how many degrees there are in a heptagon. So you might have to come back here and find out where a heptagon is to answer that question. Then I want you to find the size of an interior angle of a regular octagon. Okay, so like we've got here, a regular octagon. So what's the angle of each, what is the individual angle, okay, within an octagon? And then find the value of A in this pentagon. Okay, so I want you to have a go at all those and then come back and we'll work through each one. Okay, off you go. Magic. Have a look at that. Did a little bit of work while you paused this video. So trying to save a bit of time here, and also yeah, just using a different pen actually on the screen of my computer, which works a lot better than what I'm using at the moment. Anyway, so this first one, to find the sum of a heptagon. So how many sides does a heptagon have? If we look back at this table, we've got 7 sides. Okay, so we use our formula. So the angle sum equals 7 minus 2, so the number of sides, subtract 2 multiplied by 180. 7 take 2 is 5. 5 times 180 is 900 degrees. There's our answer. Hopefully you got that one for that one, nice and easy. Find the size of an interior angle in a regular octagon. So remember, regular, that's what we showed you here. All the side lengths and all the angles are exactly the same. All right, so to do that we need to first find out how many degrees there are in an octagon. So we again use our formula. Our angle sum equals 8 for the number of sides. 8 minus 2 times 180. Subtract that 2 from the 8 gives us 6 times 180, which gives us 1080. Then to find out what one single interior angle is, well, we've got 1, 2, 3, 4, 5, 6, 7, 8, funnily enough, 8 interior angles of an octagon. So with that answer of 1080, we divide that by 8, and that gives us 135 degrees. So hopefully you got that one as well. So our interior angle is 135 degrees of an octagon. All right, there's a better tick. All right, Last question, find the value of A in this pentagon. Okay, so again, we've got a pentagon. We need to work out how many degrees there are actually in a pentagon. So again, we use our formula. The angle sum equals the number of sides we've got in a pentagon, which is 5. 1, 2, 3, 4, 5. Penta also meaning 5. Take 2 multiplied by 180. So 5 take 2 is 3 multiplied by 180. Okay, and that gives us 540 degrees. So the angle sum in a pentagon is 540 degrees. Okay, now that we have that information, we can work out what our missing angle is down here. Okay, so first thing we do is we take all our angles, 170 degrees, our 95 degrees, our little box down here, so that's 90 degrees, and then our 80 degrees, added all them up, so 0, 5, 0 and 0 gives us 5, 7 and 9 is 16, plus another 9 is 25, plus 8 is 33, so write the 3 here, carry the 3 here, 3 plus 1 is 4, so 435 degrees all up so far. Okay, we need to get to 540, so our angle A in this case is 540 degrees, which is the total angle sum, multiplied by our 435 degrees that we have already been given in our problem, and that gives us, when we subtract that 435 from 540, 105 degrees. That easy. I reckon that was actually quicker. I might do that more from now on. Write the answers straight in and then come back and go through them. Anyway, let me know what you think of that one. But that is all. So you're now ready to get on to the second last exercise. One exercise to go. And before we go, did you hear about the guy who invented lifesavers? Apparently he made a mint. On that note, bye-bye. See you in class.